Welcome to Einstein Competition number 3. This is Mr. Bari from Columbia University, and I have my lab assistant.
My name is Isaac Bari, and I'm doing my bachelor's in math at NYU.
Also in physics as well. Okay, so the first problem.
Well,
A
okay.
plus B.
So if this is 30, that means that its x component, this way, is just going to be a's length, 4, times cosine 30, and the y component is going to be a's length times sine 30. So, of course, cosine 30.
3.5. And 4 sine 30 is
2.
Just 2. And then the other one is, can you do the other one?
Well, b is equal to, well, there's no x component and there's a y component.
So 0, 4. So now our a plus b is?
Well, that's just got to be 3.5, comma, 2 plus 4 is 6.
All right.
This line segment between where their tails meet and where these two line segments meet, and that is the direction and magnitude of our new vector.
So then r is equal to, of course, to lowercase r. Lowercase r is equal to square root of 3.5 squared plus
6 squared.
6 squared, which is 6.9.
Okay.
Right, can you write the angle equation?
Well, we actually can find the angle two different ways. Of course, the first one is just to brute force it by taking arctan of opposite, which is this opposite of this angle, which is this component,
6.
which is 6, divided by adjacent, which is 3.5, and that's equal to
60.
And, of course, the other way is to take what we know is a parallelogram. In fact, this is a rhombus because all four sides are congruent. So we can take this rhombus, and we already know this is 30, and this is parallel to the y-axis, meaning it must be perpendicular to the x-axis. So these two angles must add to 90, and 90 minus 30 is just 60. Since this is a parallelogram, that means that this opposite angle is 60, this is 120, and this is 120. And, of course, the diagonals of a parallelogram bisect the angles. In fact, since this is a rhombus, they also bisect each other. So that means that this angle right over here is 30, and that means their sum has a resultant angle of 30 plus 30, which is equal to 60.
You're going to do a minus b.
Okay, that's...
So a is, you want to do this way or you want to do other way?
Well, there are lots of ways to do it.
So it's up to you.
Now, the thing is, think about subtracting 6 and 4. What are we really doing here? We're adding 6 and negative 4. In the same way, when we're subtracting two vectors, what are we really doing? We're adding the negative version of one vector to the other. In this case, a, we already know, is 2 times the square root of 3, which is 3.5, comma 2, and b is 0, comma 4, which means negative b is 0, comma minus 4. So adding them together would just give us 3.5, comma negative 2.
Hold on, do it this way. Write then a, what is a?
3.5, comma 2.
3.5, comma 2. And what is b?
0, comma 4, which means
0, comma
4,
okay.
which means the negative version is...
Right.
Yeah, I guess you can also do it this way. 3.5 minus 0 is 3.5, and 2 minus 4 is negative 2. Now, we can also, of course, find it this way, where we take this as being A, this as being B, which means that this is equal to negative B. Then we, of course, do the parallelogram trick again. And we just find their sum like this. So the resultant vector is pointing in this direction.
So resultant is this one, right?
Yep.
So it's negative 30, but we're not going to say negative 30. We're going to say it 330. All right. So we got a plus b, we got a minus b, b minus a.
Minus a is just the negative of a minus b,
Great.
which means that in this case, it's the negative of 3.5 comma minus 2, which you'll find is minus 3.5 comma 2. But a more
Yes.
intuitive way to view it is what happens if you switch the sign of the x from negative to positive. Well, you're essentially reflecting around the x-axis. What happens if that's the x. What happens then? Okay, if
You still get 2.
sorry,
You still get 4. Answer.
yeah, well, yeah. So what happens if you flip the x-coordinate of a vector? It gets flipped over the y-axis, like this. What happens if you then flip the y-coordinate of a vector? It gets flipped over the x-axis, like this. And these two reflections produce a rotation of exactly 180 degrees.
That's right. You don't need to show this. Okay.
Which means that, of course, the angle of the angle of this right over here, this resultant, is just going to be equal to, well, this isn't actually what we were doing. This was our original resultant, and now we've just swapped it over here. So instead of it being 330, it's 330 minus this giant chunk of 180, which is equal to 150. So that means that b minus a also has a magnitude of 4, and its direction is equal to 150 degrees.
Excellent. So we now going to do a minus 2b.
So now we know that a minus 2b is equal to a minus b minus b. Now we've already calculated a minus b. That's just equal to 3.5 comma minus 2. So now we just have to subtract 4 from this one more time to get 3.5 comma minus 6. Now we just find the magnitude of that, which is
That is 7.
which
How can that be 7?
what? Yeah, I mean makes sense.
7 at what?
7 at, well, I mean you can't figure it out using traditional geometry. You'll have to use the arctan method. Make sure you're in degrees.
60.
Negative
Negative
60.
60.
Okay,
So
wonderful.
show negative 60.
So let's see if we can actually figure out the proportions of a 30, 60, 90 triangle are just this is a, this is 2a, and this is a rad 3. So we already knew if we drew this diagram once again, this is 30, and of course the length of this is 8 and the length of this is 4. So that means that when we draw this line right over here, then we can safely say this is a right angle. And that all works out in the end. This is 60, this is 30, this is a right angle too, this is 30, this is 60. So this adds up to 120, this adds up to 120, this is 60, and that is 60.
So
Which,
this one and this one is 60.
well, yeah. But since this is 30 and this is 90, 90 minus 30 is 60, which gives us the negative 60.
We've... So do you want to give us the same answer? Excellent.
Oh,
so now the Isaac is bike, right? Okay. And the bike is moving. Hold on. The bike is moving 4 meters per second. And Isaac all of a sudden throws something from the bike. And that moves 3 meters per second.
angle of the resultant vector, right over here. So we're trying to figure out that angle with respect to the x-axis. So firstly, let's find the angle of A.
No, first finish this one, baby. A to B, B to C, C to D.
Okay, so the angle between A to B is, of course, since this is parallel to the x-axis and this is parallel to the y, just 90 degrees. B to C, meanwhile, is a little bit more complicated, but still, we know this is negative 30 degrees, well, technically, 210 degrees with respect to the x-axis. So that means that we just draw this right angle right here, since this is parallel to the y, it's perpendicular to the x. So we have this 90 degree angle plus this 30 degree angle is this 120 degree angle. By the way, saying 270 degrees or 240 degrees is equally correct here. So C to D is the most tricky of them all, but by the interior angle theorem, we can say since this is 30, this is equal to 30, since these two lines are both parallel to the x-axis, and since this is 180, since these two are parallel, that means that the angle they form has to be 180 degrees, and 180 minus 30 is 150, and 150 minus 60 is 90. That means we have another right angle here. But, of course, the total resultant isn't just the sum of these. That's impossible. So how can we find the resultant?
No, first find the angle of the A, and then B, and then C, and then D.
Well, yeah, I suppose that works. A is just 0 with respect to the x-axis. It's parallel to the positive x-axis. B is 270, as you can see. And by the way, when you're figuring out their direction, imagine you've got a tiny little arrow pointing outward, and you're just spinning it around, and you're seeing what angle it matches up with these. So, for C, what do we get? Well, that's just going to be that 180 plus 30, which is equal to 210. For D, we can see that it's 60 from this side, which means it's 120 from this side. Alright, and now to find the resultant, first we have to take the sum of all of these vectors. That's what's going to get us the resultant vector in the first place. So A is, of course, 100 comma 0, since it's parallel to the x. B is 0 comma minus 300. C is, well, we can see that this is going to be what? 150. What angle is this? 30. This is 150 sine 30, negative 150 sine 30. And this angle right here is 150 cosine 30, which is negative 75 and 75 rad 3, respectively. And finally, D, 200 meters at an angle of 60, not with respect to the x-axis, of course, with respect to the negative x-axis.
I believe this one also negative, baby, 75 rad 3.
Yeah, as you can see, these two are, wait, no, it's not 75 rad 3, because these two aren't the same length.
Oh, no, you didn't write negative over there. 75 rad 3.
Sorry, this is also pointing in the negative direction. Okay, and finally, D, what do we get? Well, this is just going to be negative 100, and this is pointing in the positive y direction, so we write positive 100 rad 3. So, all in all, we get a vector that's pointing in the negative in both directions, which is R.
That's bad for camera, baby. Red.
Oh, so why'd you write
Sorry.
R is equal to, what's the sum of these? These two cancel out, so we get negative 75 rad 3. And what's the sum of these? 100 rad 3 minus 375. Now, all we have to do is just take arctan of what? Well, this is clearly the bigger component. 100 rad 3 minus 375.
That's negative 202. Negative 202. Negative 202.
Oh, yeah, okay, so you're just going to feed it to me. Well, what's negative 202? Oh, this?
Yes.
But we don't need that for the arc cam.
Oh, we don't. Okay.
Negative 75 rad 3. Okay, so to find arctan, all we have to do is just take, let's see, opposite, which is negative 75 rad 3, and divide it by adjacent, which is 100 rad 3 minus 375. So let me just enter that into the computer real quick. And that is approximately 33 degrees right here. But of course, that's not the final angle. The final angle has to be adding, wait a second, oh crap, sorry. 33 degrees is related to the final angle. Why? Because it's the angle between this and the negative y-axis, right over here. Which means the total angle is 270, so the final answer is 270 minus 33, which is equal to 237.